All right, you brainiacs, buckle up. We're going deep on some seriously mind-bending physics shit today. We're talking about the goddamn Higgs boson.
The God particle.
You know it. The one that had scientists jerking off for decades trying to find it.
It's true. The Higgs boson was a pretty big deal in the physics world.
Big deal. It's the fucking keystone to the whole goddamn universe.
At least that's what they tell us.
Okay, so let's cut the crap and get down to the nitty-gritty.
Sure.
What the hell is this Higgs boson? And why should we give a shit? You know, in simple terms, for those of us who didn't spend our lives sniffing textbooks.
Okay, think of it this way. The universe is like a giant party, filled with particles bouncing around doing their thing.
A cosmic rave. I like where this is going.
Actually. Now, the Higgs boson, it creates a field that permeates the whole universe, and we call it the Higgs field.
Right.
And this field, it's kind of like this sticky goo that's everywhere.
Sticky goo. Sounds messy.
Well, not goo in the literal sense, but it does interact with particles. And the way particles interact with this Higgs field determines how much mass they have.
So particles are wading through this cosmic goo, and the more they get stuck, the heavier they get.
That's a pretty good analogy. Particles that interact strongly with the Higgs field get bogged down, gives them more mass.
Right.
While others, like photons, they just zip through, staying massless.
So this Higgs field is basically a cosmic scale. Weighs particles, mind blown. But where the hell does the Higgs boson fit into all of this?
The Higgs boson is like a ripple in this field.
Huh.
It's like a little blip that proves the field is actually there.
So they needed to find this tiny blip to confirm the whole goddamn field exists. Seems like a lot of effort for a ripple.
Well, it was a massive undertaking. Scientists spent decades building giant particle accelerators like the Large Hadron Collider,
Right.
just to smash atoms together and hope they'd catch a glimpse of this elusive particle.
And they finally found it right. In 2012, that was big news, even for us non-physics folks.
Yes. In 2012, physicists announced they had finally detected a particle with the properties predicted for the Higgs boson.
Huge.
It was a monumental achievement, confirming a major piece of the standard model of particle physics.
Standard model. Sounds like some boring rule book.
It is sort of a rule book, but it's the rule book for the universe. It describes all the fundamental particles and forces that make up everything we know.
Okay, so finding this Higgs boson was like finding the missing page. That explains how mass works in this cosmic rulebook.
Exactly. It tied a lot of things together. And for a while, everyone was pretty damn happy.
Hold up, you're saying for a while. Did something go wrong with this happy ending?
Well, let's just say the Higgs boson brought its own set of mysteries. Like, why the hell is it so light?
Light? You mean like it doesn't weigh much?
Well, it has mass, but it's much lighter than what the standard model predicts it should be.
So this cosmic scale is broken. That's reassuring.
Not exactly broken, but definitely a bit wonky. This discrepancy between the predicted mass and the actual measured mass of the Higgs boson, it's what we call the hierarchy problem, and it's a major headache for physicists.
A hierarchy problem. Sounds like some elitist physics club bullshit.
It kind of is.
Yeah.
But it points to something we're clearly missing in our understanding of the universe. You see, the math suggests the Higgs should be interacting with all these virtual particles popping in and out of existence.
Right.
And this interaction should give it a massive mass, way heavier than what we observe.
Virtual particles. Is this where shit starts getting really trippy?
You could say that. These virtual particles are like ghostly particles. They exist for a fleeting moment, influencing the behavior of real particles. And according to the math, they should be making the Higgs super heavy.
But it's not super heavy, which means...
Which means something is either wrong with our calculations,
Right.
or there's some other mechanism at play that we don't understand, something that's canceling out the effects of these virtual particles and keeping the Higgs relatively light.
All right, that's some deep shit. So this Higgs boson is a troublemaker, huh? Throws a wrench in the whole goddamn cosmic machine.
It definitely throws a wrench in our understanding, but that's what makes it so exciting.
Okay, you're starting to sound like one of those physics nerds who gets off on this stuff.
Well, I can't deny it's fascinating. The Higgs boson has opened up a whole new world of questions and mysteries.
Right.
And it's driving us to look beyond the standard model for answers.
Beyond the standard model? What the fuck does that even mean? Are we talking about a parallel universe where the Higgs boson is a goddamn heavyweight champion?
Maybe not a parallel universe, but definitely new physics.
Okay.
We might be dealing with new particles, new forces, even extra dimensions.
Hold on, extra dimensions.
Yeah.
We're talking about some interdimensional shit here.
It's a possibility. Some theories propose that there are extra spatial dimensions, curled up so small that we can't perceive them directly, But gravity might be leaking into these dimensions, and that could explain why the Higgs is so light.
Okay, now my brain is officially melting. Extra dimensions, virtual particles, a cosmic scale. This is some next-level shit. I need a drink.
I think we both do. But before we hit the bar, we've got to dig into some of the weirder implications of this Higgs business.
All right, you're on. But keep it simple. My brain can only handle so much cosmic weirdness in one sitting.
No problem, we'll break it down. But trust me, it's going to get even weirder. All right, let's pick up where we left off. Teetering on the edge of the goddamn abyss, staring into the face of cosmic weirdness.
My brain is still buzzing from all that talk about virtual particles and extra dimensions. So where do we go from here?
Well, one of the most intriguing aspects of the Higgs field is its relationship with mass.
Right, we talked about particles interacting with the Higgs field to gain mass.
Right.
But how the fuck does that actually work? It's still pretty fuzzy in my mind.
It's all about interactions, man. Imagine the Higgs field as a giant, invisible spider web that spans the entire universe.
A cosmic spider web. That's a new one.
Bear with me. Now, different particles are like different insects flying through this web. Some, like the hefty top quark, get tangled up in the web, slowed down by the sticky strands. That's how they gain a lot of mass.
So the top quark is like a bumbling beetle stuck in the web.
Exactly. While other particles, like the sleek and speedy photon, they just zip right through, barely touching the strands. They remain massless.
So the photon is like a goddamn ninja, slicing through the web with ease.
Perfect analogy. It's the strength of the interaction with the Higgs field. That determines how much a particle resists change in motion, what we experience as mass.
Okay, I'm starting to see the web. But tell me, what the hell determines how strongly a particle interacts with this field? Is there some cosmic rulebook for that too?
That's the million-dollar question. We don't have a definitive answer yet. The standard model tells us how particles interact, but it doesn't explain why they interact with different strengths.
So it's like knowing the dance moves, but not knowing why some people are better dancers than others.
Exactly. It's a mystery that keeps physicists up at night. It's like the universe is playing a game with us, giving us hints, but not revealing all its secrets.
Sounds like a frustrating game.
It can be, but that's the beauty of science, isn't it? The constant pursuit of knowledge, the thrill of discovery.
You scientists are a weird bunch. You get off on the unknown.
We do. It's what drives us. Now, back to the Higgs.
Hold on. Before we get lost in the cosmic web again, let's bring it back down to Earth for a second. Does all this Higgs shit actually have any real-world applications? Or is it just theoretical mental masturbation for physicists?
That's a fair question, and the answer is yes. Understanding the Higgs boson and the Higgs field could have profound implications for technology and our understanding of the universe itself.
All right, I'm listening. Hit me with some real-world examples.
For starters, let's talk about superconductivity.
Superconductivity. Sounds like some superhero power.
It kind of is. Superconductors are materials that can conduct electricity with zero resistance. Imagine a world where you could transmit power over vast distances without any energy loss.
That would be fucking awesome. No more energy bills.
Potentially. But the problem is that current superconductors only work at extremely low temperatures, making them impractical for widespread use.
So how does the Higgs come into play?
Well, the way electrons interact with the Higgs field affects their conductivity. If we could understand and manipulate this interaction, we might be able to create superconductors that work at room temperature.
That would be a game changer. We're talking about revolutionizing everything, from electronics to transportation.
Absolutely. And that's just one example. A deeper understanding of the Higgs mechanism could also lead to advancements in material science, allowing us to create materials with unprecedented properties.
I'm starting to see the potential. So this Higgs boson, it's not just some abstract concept. It could actually lead to some mind-blowing technological breakthroughs.
Exactly. But beyond the technological implications, the Higgs boson also offers us a deeper understanding of the fundamental nature of reality.
Hold on. Let's not get too philosophical here. I'm still trying to wrap my head around the practical stuff.
Fair enough. But let's not forget the sheer intellectual achievement of discovering the Higgs boson. It was a triumph of human curiosity and collaboration, demonstrating our ability to unravel the mysteries of the universe.
Yeah, those scientists at CERN are pretty badass. They built a goddamn machine to smash atoms together. and find a particle no one had ever seen before.
It was an incredible feat of engineering and scientific ingenuity, but the discovery also raised more questions than it answered.
Right, we talked about the hierarchy problem, that pesky little mass discrepancy.
Yes, the hierarchy problem suggests there's something we're missing in our current understanding of the universe. It's like a crack in the foundation of the Standard Model, hinting at a deeper, more profound theory waiting to be discovered.
So the Higgs boson, it's like a key. That unlocks a whole new realm of physics.
Precisely. It's a gateway to new particles, new forces, maybe even new dimensions.
Right, now you're just messing with me. New dimensions. I thought we were done with that trippy shit.
We can't rule it out. The universe is full of surprises, and the Higgs boson, it's just the tip of the iceberg.
Okay, I need a moment to process all of this.
Yeah.
This Higgs shit, it's a wild ride.
It is. Buckle up, because we're about to dive even deeper into the rabbit hole.
Oh, fuck.
All right, so we've journeyed through the sticky cosmic web, glimpsed the shadows of extra dimensions, and grappled with the weight of the hierarchy problem.
My brain feels like it's been through a particle accelerator.
Yeah.
So where do we land after this wild-ass ride through Higgs land?
Well, I think the biggest takeaway is that the Higgs boson, it's not just some obscure particle in a physics textbook. It's a fundamental part of our reality, a cornerstone of our existence.
Okay, that sounds deep, but let's be real. Most people are more worried about paying their bills and getting laid than pondering the meaning of existence.
True, but understanding the Higgs boson, it's not just about abstract concepts. It has the potential to revolutionize our world in ways we can't even imagine yet.
Right. We talk about superconductivity and new materials. That's some serious next-level shit. But is there anything else this Higgs thing can do for us?
The possibilities are endless. For example, the Higgs field could play a role in cosmology, helping us understand the evolution of the early universe.
Cosmology, you talk about the Big Bang and all that shit.
Exactly. The Higgs field may have played a crucial role in the rapid expansion of the universe just after the Big Bang, a period known as inflation.
Hold on, so this tiny particle could hold the key to understanding the entire history of the goddamn universe. That's insane.
It is insane, but it's also incredibly exciting. And that's just one avenue of exploration. The Higgs boson could also shed light on dark matter and dark energy,
Okay.
two of the biggest mysteries in modern
The
physics.
dark matter and dark energy, those are the things that supposedly make up most of the universe, right?
Oh, exactly. We know they exist because of their gravitational effects, but we have no idea what they actually are. Some theories suggest that the Higgs field could interact with dark matter particles, potentially providing a way to detect them.
So we could finally solve the mystery of what makes up the majority of the universe. That would be a Nobel Prize-winning discovery right there.
It would indeed, and there's even more. The Higgs boson might even be connected to the origin of mass in the universe, perhaps even the origin of the universe itself.
Okay, now my head is spinning again. We're talking about some serious existential shit here.
It is deep stuff, but that's the beauty of it. The Higgs boson, it's a portal to the unknown, a catalyst for further exploration and discovery.
So where do we go from here? What's the next step in this Higgs-fueled adventure?
The journey is far from over. Scientists at CERN and other research facilities around the world are continuing to study the Higgs boson in more detail, probing its properties and interactions with other particles.
They're still smashing atoms together, hoping to squeeze out more secrets from this elusive particle.
Exactly. And who knows what they'll find? New particles, new forces, new dimensions. The possibilities are mind-boggling.
All right, I'm officially hooked. This Higgs boson, it's a goddamn enigma. A puzzle that keeps unfolding, revealing new layers of complexity and wonder.
It is. And the more we learn, the more we realize how much we don't know.
So we're basically at the beginning of this whole Higgs saga.
We are, and that's what makes it so exhilarating. We're on the cusp of a new era of discovery, a revolution in our understanding of the universe. And the Higgs boson, it's leading the charge.
Oh, shit. I can't wait to see where this wild ride takes us next. But for now, I think I need a stiff drink and a good lie down. My brain needs a break from all this cosmic weirdness. All right, listeners, we waded through the theoretical swamp, smashed some particles, and emerged from the other side with a newfound appreciation for the goddamn Higgs boson. It's a particle, it's a field, it's a mystery, it's a key to unlocking the secrets of the universe, and the search continues. We'll catch you on the next deep dive where we'll explore some other mind-bending corner of this crazy-ass cosmos. Until then, keep your minds open, your curiosity burning, and your drink strong.